similar circles. Prove that all circles are similar using translations and dilations. Remember, translation is a slide. Dilation is like your eye expanding, enlarging, or reducing, shrinking. So, concentric circles, what are they? The simple one is it's a circle within a circle. But the technical math is they are coplanar circles. Coplanar meaning on the same plane that have the same center. Remember, pause anytime you need to. So are these two circles similar? Well, remember, similar means one is just a smaller version or a larger version of the other one. Alright? So we're going to see if we can prove that these two are similar. So first, we translate circle A to circle B. So we're going to take the bigger red circle, well, on video, not on your nose, but the bigger red circle and move it to B. So here's the center of A. Here's the center of B. So we're going to translate X, Y. So what do we have to add to X to get over here? So we're going to move right 1, 2, 3, 4, 5. So that we're right underneath there. So we're going to add 5. And then we're going to go 1, 2, 3, 4, 5. We're going to go up 5. Alright? So we're going right and up. And we end up at the same center. So, a little smartboard magic here. Okay. If I took this, that didn't work. Oops. So much for my smartboard magic. Put that back. If I take this, see the center I still got there? So if I take this, I lost my center. Dang it. One, 2, 3, 4, 5, and then up 1, 2, 3, 4, 5. And notice I have just moved to where the centers are lying on top of one another. Like this much better drawing, but I wanted to see it actually move. Next, we use a scale factor to dilate. Okay, so let's look at what we have here. What is the radius of the smaller triangle? Wow, circle. 1, 1, 2. Okay, so circle B has a radius of 2. Now let's look at circle B. 1, 2, 3. Okay, has a radius of 3. So therefore, the scale factor is 2 to 3. Okay, and notice I didn't put 3 over 2, and that's because of this. The scale factor will always be the final circle divided by the pre-circle. So since I was moving A onto B, B is my final circle. And so therefore, I use the radius of B on the top, radius of A on the bottom, 2 to 3. So remember, scale factor mapping a smaller circle onto a large circle is an enlargement. And going from a large circle onto a small circle, which we just did, is a reduction. Now, are these two similar? Well, yes they are. Because look what we have. We have one triangle. Wow, several triangles today. one circle on top of the other one. So this is our final step. We use the scale factor to dilate circle A. So if we do a scale factor of 2/3 on our circle, we now have made one circle the same size as the other one. We basically shrunk A down to B. All right. Now, all circles are similar. Why is that? Because we can translate any circle and then use the dilation to make them the same size. So first we line up the centers through translation and then dilate to make them the same size. So try this one. We're going to translate circle A onto circle B. So this time we're taking A and we're going to move it to B. Okay? So X. How do we move our X's? So we're going to go left 1, 2, 3, 4, 5, 6, 7, 8, 9. So we moved left 9. And now we're going to move down 1, 2. So down 2. Okay? Those are supposed to be parentheses, but we'll just make it look like that. Okay, so we went left 9, down 2. Now, scale factor. Let's look at the radius of our final one. So the big one. 1, 2, 3. And the scale of our starting one was 1, 2. So our scale factor is going to be 3/2. If we apply that, we'll get the same size. In other words, we're taking the smaller one, A, and making it bigger. Notice this is bigger than 1. So we're going to make our circle bigger to line up and match B. That's what we're saying. We're going from A to B. And if we apply 3/2 to A, we end up with the same size circle B. Okay, you have two choices here. You can actually go back and use a previous one and find out where 5, 2 is, for the center, and -3, 6. -3, 6 is up here, and you could physically count there. Okay? So, to go from here, we go 1, 2, 3, 4, 5, 6, 7, 8, and up 1, 2, 3, 4. So you can use another piece of graph paper to do that. Okay? And that tells you that we're going to go left 8 and up 4. That's our vector. Another way to do it is, since we're starting with B, okay? Because we're going A on to B, which means that's our final one. So we're going to start here, and we actually do the math. -3 minus 5 equals -8. That's for our X value. And for our Y value, 6 minus 2, which is 4. And that's where we get our vector. If that's too tough, just go to a piece of graph paper, an XY grid, and map it out that way, and then just move it. All right? Now, over here, what scale factor would be to make circle A the same size as B? So remember, we're making A into B. So B is our final answer, our final figure. So that one always goes on top, and the original one on the bottom. So 12 divided by 3 is 4. So it's a scale factor of 4. Because remember, we're trying to make A into B, so we're going to have to multiply by 4 to make it bigger. Let's try this again. Again, you can go back to the map and use that, or A onto B. So this is our final, so that's going to be our starting point. We're going to do our x first, 5 minus -2, which is 7. And then our y, -5 minus 0, which is -5. So that is a vector of 7, -5. Alright? I don't know why I said parentheses earlier. They are supposed to be those symbols for vectors. Just lost them a little bit. So I apologize. If you want to go back and change that, yes, this should be vectors. There should be those funky triangles on the side. So back to here. Again, if you want to, you can go on to a grid, put a point at 5, -5, put a point at -2, 0, and move it and count whatever works for you. But basically, you're going to go right 7 and down 5. And again, if you need to see that on a grid, go back and do it. You can visually see it. No big deal. Now, we're going to go A to B. We're going from here to here. This is our final. So that always goes on top. And think about it. We're making, going from A to B, we're making it smaller. So it really should be 3 over 15. 15 over 3 wouldn't make sense, because that would reduce to 5, and that is making something bigger. This is 1/5. So if we multiply by 1/5 of a scale factor, it's going to get smaller. It is a reduction. And that's it for the notes.